To begin our study on thermodynamics, I am starting by giving you an introduction to thermodynamics, kind of set you up for the topics coming up later on in thermodynamics. The first question that obviously comes to mind is, what is thermodynamics? As the name suggests, thermo and dynamics, basically it is a study of heat and other forms of energy. So essentially we are studying the relationship between heat and other forms of energy. Mostly we will be studying the relationship between heat and work. Work is, as you know, is another name for energy. Work and energy are interconnected. So basically our focus will be to study the relationship between heat and work. Let me begin by talking about or taking a few examples which connect heat and work. Let us say we have a container in which we have some quantity of water. And let us say we want to raise the temperature of this water through, say, 2 degrees Celsius. Now I have two options. One option is to add heat of this water on a flame of gas. The other is to stir the water. So I can have a stirrer inside this water and I keep on stirring the water, and over a period of time the temperature of water will rise. Basically the stirring of water is doing work. So what I see is, if you want to raise the temperature of water, you can either give it heat or do work. And in both the cases you will end up with the same, or you can end up with the same result. One more example. In this case, instead of just raising the temperature, say change of state. Say we have an ice cube at 0 degrees Celsius and you want to melt it. So again you have two options. One is add heat. So heat it up, keep it in the sun, keep it on a flame, it will start melting, or just keep it over there at room temperature and it will start melting. So basically you are giving heat. The other is by rubbing it with maybe another ice cube. So I take another ice cube and rub it off both the ice cubes with each other. Friction will be created that will generate heat and then start melting. So this is again by doing work. So heat and work. So I'm able to raise the temperature of an object by either giving it heat directly or by doing work. Also, heat can generate work and work can generate heat, as we saw in these cases over here. Let me give you one or two more examples of these two, heat and work. For example, heat generating work. Let us take the example, say for example, of a bicycle wheel. You have a rubber tube inside this, which is filled with air. And when you are driving it out in the sun, because of the temperature, because of the atmospheric temperature, the air inside this tube gets heated up and it expands the tube. So it is an example of heat creating or doing work. The heat of the sun is expanding the air which is there inside the tube. In the process, the tube expands. That means work is being done. Work getting converted into heat energy. One more example is, let us say we have a metal sheet and you want to drill a hole into it. So you keep it under a drilling machine and this drill starts drilling this hole into this. This is rotating, so work is being done. This is mechanical work, and when this drilling happens, a large amount of heat is generated over here. This is another example of work getting converted into heat. Based on all these examples, what we can say is that work is a form of heat energy. And therefore they are intimately connected to each other. So this is the relationship between heat and work, and this is more of a qualitative relationship between both of them. What about the quantitative relationship between heat and work? James Joule is given the credit for getting a relationship, a quantitative relationship between heat and work. He conducted the famous Tyrell Experiment. We'll briefly talk about that experiment over here. So what he did was he made an arrangement something like this. So he had a spindle on which he had these paddles mounted, and this was kept inside a container with some liquid. So you had this liquid over here, this, and of course this was insulated, and there was a facility for measuring temperature. Let us say this is temperature measuring device, and this was connected to a system wherein you had a rope or thread, and this thread was connected to a pulley, and this was connected to weights. Same over here, you had a pulley, and then this connected to weights, and these weights were allowed to fall down. So when this weight fell down, they rotated this spindle. In the process, these vanes or paddles rotated in this water, and what was observed is the temperature of water increased. So this was a setup which converted mechanical energy or work, when these were rotating, was work, into heat energy. So work was getting converted into heat energy, and he conducted this experiment with different liquids, and he came up with the conclusion that 1 calorie is 4.18 joule. Calorie is the unit of heat, joule is the unit of work done, and he gave this quantitative relationship of 1 calorie is 44.18 joules, and this is known as mechanical equivalent of heat. We'll be using this relationship 1 calorie is 4.18 joules quite frequently when we study thermodynamics. So this part was about the qualitative relationship between heat and work, and here we've looked at the quantitative relationship between heat and work. Right. To end the video, what I'll do is I'll talk about a few applications of thermodynamics. Right? For example, one of the first application that we can think of is a boiler. Right? In boiler, what happens is heat energy is used to convert water into steam, right? And then steam is used to run turbines and generate power. So you're basically using heat energy to do work, and this is an excellent example of the use of thermodynamics or the application of thermodynamics. Another more example which all of you must be using is IC engines. Right? Two-wheelers use IC engines. In that you have a combination of fuel and air, right, which is used to run the IC engines. Again, heat energy being used to convert into mechanical energy. Right? And also the refrigerants, refrigeration systems, refrigerators. And the extraction of heat by a refrigeration system is an example of thermodynamics. So these are some of the common examples of applications of thermodynamics, and if you plan to study engineering in future, you'll be studying these things in more detail. Okay, with this background, you'll be better equipped to understand the topics on thermodynamics that are coming up in the future videos. Thank you.